9 out of every 10 construction projects go over budget or finish late. And it's not because project managers are lazy or stupid. Well, I mean, sometimes it might be, but mostly it's because of this massive problem we have called uncertainty. When we plan and prepare for a construction project, we don't know the exact ground conditions, we don't know what issues we're going to have with our supply chain, and we don't know how much it's going to rain. And as a project manager, we can't actually control any of that. However, we are responsible for it, which might seem unfair, but it's actually why project management as a framework exists. So in this video, I'm going to give you a complete approach to project management. We'll cover what a project actually is, why project management is a framework, 3 things we're actually working towards, the core skills we need to master, and the 5 phases of every project. Explain all these different concepts and how they all fit together to give you a practical approach you can use to control uncertainty and more successfully deliver projects. So the first thing I want to tackle is this big myth that if we plan hard enough, if we prepare for everything, the project is going to go according to plan. So firstly, we just have to accept that there are things outside of our control. The ground conditions, the weather, the supply chain, and 1,000 other things that will happen on any project that we cannot possibly predict. We have to accept the reality that we cannot control the inputs. Other thing that makes this more challenging is we don't actually get any second chances. Project management and construction projects are fundamentally different to something like manufacturing, where we're doing the same thing over and over again, and we can iteratively improve the processes. Projects are fundamentally different. We don't get any second chances. The only thing we can actually control is how well we prepare for things to go off track and how we respond to them. A profitable on-budget project isn't actually a project where no problems came up. It's a project where problems were handled well. Project team was proactive rather than reactive. And fundamentally, project management is a framework we can use to deal with uncertain, ever-changing environments, but maintain this proactive approach to delivering a project. Core idea behind this entire video and everything I'm going to talk about is this idea that project management is a framework that gives structure to uncertainty. Every project is different, but they're different in this repeatable, structured way where we can actually build a framework or a pattern that we use to deliver every project we work on. So while we're always building something that's different, we're always following this same set of processes. At the start of the project, we have to actually work out and understand what we're building. We have to prepare an estimate or a feasibility to do that. We have to go through some design development process and manage the design. We then plan and prepare for the construction. We engage subcontractors. There's all these repeatable steps within this uncertain environment that we do in this consistent way. So while the specifics will be ever changing, the overall process is actually consistent. So the framework can't tell us exactly how much it's going to cost to build this road. It can simply tell us how to work it out. If we think about an analogy from the airline industry, a pilot will still do the same pre-flight checklist before they take off. Checklist doesn't mean nothing unpredictable is going to happen. It just means the pilot is going to be as reliable as possible despite it. And the other point I want to make is that project management isn't really hard. I like to think of it as common sense on steroids. Nothing here is about being super clever or intelligent. It is about being disciplined and consistent. So with our project management framework, we're actually going to gain 4 things. We're going to gain consistency, which means we're going to follow the same approach on every project. So people and systems transfer, even though we've never done that exact project before. We've got focus. We know the outcomes we're working towards, and we have a goal we're working towards. We're going to have fewer chaotic, reactive decisions. Most of our thinking and preparedness is done up front. We maintain a risk register. We know the things that could possibly go wrong and we prepare for them. And then this entire framework is repeatable. All right, so I wanted to start with setting the scene and going over a few of those sort of core ideas that we should have in the back of the mind when we think about the application of project management. Now, I want to define a little bit of terminology that's going to matter. So, number one, what actually is a capital project or a project in general? So, when we think of a construction project or capital project, which is the term that's often used in the industry, is we're thinking of any instance where we have a massive upfront investment in terms of capital and resources to build something. These are long life physical assets like roads, hospitals, solar farms, power plants, basically physical infrastructure assets. They'll generally have an owner who's financing and deciding what to build, and a contractor who delivers the project for them. Now, when we think about what this actually involves, it is a physical construction asset that's being created. It is a one-off process. It doesn't happen over and over again. It's not like manufacturing. And importantly, which is where we just draw a distinction between the other sorts of project management, like software project management, is that it involves a huge expenditure of resources. And once you commit these resources, it then becomes very expensive to change things. For example, if you're building the concrete slab of a building or a basement, then you can't change the thickness after the concrete's been poured. It would be a very expensive exercise to do this. So this means that we really have to define upfront what we're going to do. Again, software project management is a bit different because it is much easier to change a line of code than it is a concrete structure. So because of this, capital projects or construction projects are fundamentally different to other types of projects because we have a huge expenditure of resources and we're creating something that once it's built is very hard to change, which means there's a couple of core concepts we have to understand about the timing of these projects. Number one is what is referred to as the influence and cost curve. What this basically means that at the start of the project, we have the most ability to influence the success of the project. For example, we can change the thickness of the concrete basement to be the correct thickness. But once we have made that decision as the project progresses, it then becomes very expensive to implement change. So what's important to understand is at the start of the project, early on in the project lifecycle, we have a lot of ability to influence the outcome and success of the project. And as the project progresses, the cost of implementing change becomes much higher. Now, the actual challenge to following this in practice is, again, when I spoke about in the introduction about the impact of risk and uncertainty, is we also have the most uncertainty early on in the project, which means there's the most unknown unknowns. There's things we can't control. We don't know how much it's going to rain. We don't know what issues we're going to have with our suppliers and subcontractors. So we actually have the least amount of information. So we have the greatest influence, but we have the least information to act on. So we're kind of between a rock and a hard place. We have limited information, but maximum influence, as opposed to when we have the most information, we actually know what's happening. It is the most expensive to influence change. It's very important to understand this trade-off because it frames how you think about project management. The other curve to understand is the expenditure curve. So what generally happens on a project is you're spending small amounts of money and getting small amounts of work done. You ramp up in the middle of the project, and then you have a long tail end when you sort of demobilize and close out defects, which really means, when we think about this practically, most of the money is probably spent by around 50 or 60% through the project because you have this long tail at the end where you're finishing the project. And I guess what can we practically do with this information? Well, we really want to front load our decisions and planning, factoring in the lack of information because most of the money is going to be gone by 70% of the way through the project. So we really need to be front loading our investment in the planning and deciding what we're going to do. Okay, so depending whether you've read PMI, Project Management Institute's PMBOK or some other project management frameworks, I honestly find these a little confusing and complicated. My very simple framework to think about project management is as follows. We have outcomes, so the goals towards which we're steering. We have skills, which are the capabilities we apply to them. These are things like estimating, scheduling, cost control to get work done. Now, I'll talk about in a second why I believe skill is the best term to use rather than a process, because all these PMBOK institutes, they use the term process, and it is an important concept to understand, but I think the foundation behind it is the actual skill. And then we have the phases where we do the work. So repeatable sets of activities that occur throughout the project where we do work. We can think of this as the outcome as the why, the skill as the how, and the phases as the when. All right, so I toyed a little bit between calling the how step a skill or a process. And Fundamentally, I think this is the distinction that matters. To have a skill, like to know how to perform an estimate, you have to actually know the process, but you also need the judgment of when to apply it. So by having a skill, it implies that you understand the process, but you also have this extra layer of judgment to apply it, of when to apply it. So every skill sits above a process. It has a process within it. So estimating, cost control, scheduling, procurement, they have a process, but then they also have to be applied by an individual who is applying that skill. So if we think about, for example, scheduling, so there is the process of building a schedule, which is creating a work breakdown structure, putting your activities in sequence, estimating activity durations, and then optimizing and analyzing the schedule and the mechanics of how you calculate the critical path. But then there's the judgment factor behind it, which is actually understanding the methodology, when it makes sense to go into more detail versus less detail, basically what activities are likely to slip, and even though they have low float, would realistically sit on the critical path. To me, that is judgment that you're never going to be able to capture that level of detail and the methodology behind it that someone who's skilled and experienced has. So a process is an important part of a skill, but the skill itself also includes the judgment and execution by someone who really knows what they're doing. Okay, so tying this all together, this is the framework I'm going to give you to manage a project. And again, I'm going to explain why these are the specific headings as we go on. But we've got our outcomes, which are safety and our ethical responsibility to making sure we deliver the project with nobody getting hurt. We've got the cost side of it, so actually doing the work under budget. And then the third part of this is stakeholder satisfaction. I'll discuss how all of our other, what people often refer to as outcomes, such as finishing on time or like quality, how these fall under these three headings. Then we've got the actual workflows we follow to do this, our skills, which are leadership and emotional intelligence, estimating, quantities, scheduling, procurement, contracts admin, cost control, risk, quality, safety, design management, doc control, stakeholder management, change management, and commissioning. And then we have the phases these are applied across: our strategy and business case, planning and design, procurement, delivery and construction, and handover and closeout. Okay, so now I want to dive into the outcomes, the skills, and then the phases. So number one, the outcomes. And basically the idea behind this is for a framework to work, we need to have an outcome that we're optimizing towards. And I believe there are three outcomes for any construction project. Outcome number one is safety. Safety is always going to be our first priority. And when I say safety, I also extend this to basically environmental and the overall delivering the project in a way where we do no harm. Now, this is an ethical responsibility that we have as project managers. It is our ethical duty to make sure nobody gets hurt and everybody's safe. Finishing the project under budget, keeping our stakeholders happy to some degree is negotiable, but making sure we do this without anybody getting hurt is absolutely essential and our ethical responsibility as project managers. The next outcome we have is cost, which is basically making sure that we deliver the project for less than its budget so we generate a profit. From the perspective of the owner, this means that we get a net positive return on our feasibility study. And from the perspective of the contractor, it means we generate a profit because we charge a client more than it costs us to do the work. Obviously, as a business in a capitalist society, this is absolutely essential. Now, important framework here is if we're talking about publicly financed projects, for example, building hospital, there is some social benefit to this, and it's the role of the government to determine what that is. But at the end of the day, that value will always have a price tag associated with it. So we still have to deliver the project for less than we budgeted to ensure we're meeting the objectives. The third outcome of the project, and these are the three distinct outcomes that I think everything else falls out of, is stakeholder satisfaction. So for a capital project, the stakeholders are the funders, we've got members of the community, we've got the people impacted by and are going to be using the project. Is basically we need some degree of satisfaction that we have fulfilled the original requirements of the project to keep our stakeholders happy. Our clients happy. If we're a contractor, they're going to give us new work. For the public, if we build a hospital, that the hospital is actually going to function as required and do what it was intended to do. Everything downstream of this will fall out of these three outcomes. For example, finishing the project on time really is about getting cost and stakeholder satisfaction. For example, if we're the contractor, if we don't finish the project on time, we'll incur liquidated damages, we'll pay extended indirect and overhead costs, we'll pay our project manager for 12 months instead of 6 months, and all of this impact our bottom line. it's also going to be bad for our stakeholder satisfaction because they want the hospital open on the 1st of December and they're getting it 6 months later, which means 6 months of not being able to do operations and actually use the asset as intended. When we talk about scope, again, that comes back to cost. We, as the contractor, we actually have to build what we will say we're going to build to get paid for doing the work. And again, stakeholder satisfaction, because if we are contracted to build a hospital and it needs a certain level of lighting in the operating theaters so the surgeons can do surgery correctly, that scope is defined, but it comes back to the stakeholder satisfaction and actually fulfilling the needs of the project. If we think about an aquatic center we're building and the aquatic center opens 12 weeks late, even if nobody was hurt, we filled our ethical responsibility and we've built what we said we were going to do. But that 12 weeks late of the project, we've incurred liquidated damages and we've paid our site recurring costs at an extra $80,000 a week, for example. We're $1 million over budget. Plus, the whole summer, the council couldn't use the swimming facility. So we've got a dissatisfied client. So as you can see, a lot of these other outcomes that I believe people incorrectly specify as outcomes really fall under these three headings: our ethical responsibility to complete the project, to do so under budget, and to make sure our stakeholders are satisfied with what we're delivering. Okay, so those are the outcomes. The skills are the levers. They're the processes we actually put in place. Every skill protects one or more of these outcomes, and every skill cuts across the project phases. So again, the reason I prefer the term a skill rather than a process is a skill is people first. The process tells you what to do. The skill, or the actual person, needs to apply the skill with judgment to make sure we get the best possible outcome. Okay, skill number one, I believe, is leadership, communication, and emotional intelligence. And that's because projects are built by people, and managing people is actually the core skill that sits below everything else. We have subcontractors we work with, we have clients we need to work with, we have external stakeholders, we've got a project team. Basically, we need to be able to be the ones communicating effectively with these people and making sure that we're not getting into disputes that derail the project. So leadership and emotional intelligence is going to sit behind everything. Skill number two is estimating. Estimating answers the question of how much is it actually going to cost to deliver the project. And we do this when we're preparing our feasibility or getting ready to sign a contract. So being able to work out how much something costs before we do it is obviously incredibly intrinsic to this idea of stakeholder satisfaction, and basically making sure that we deliver a project where the value exceeds the cost. The only way we can know that is if we're accurately calculating the costs. Now, quantity takeoffs I break out as separate to estimating because all construction projects are driven by quantities. It's a very important concept to understand that a project where we're doing 100 meters of trenching is clearly completely different to a project where we're doing 2,000 meters of trenching. We're going to have different methodologies. We're going to have a different duration. We might need different subcontractors. We're obviously going to have a different cost. So being able to actually look at a set of construction drawings and blueprints, a 3D model, and to work out the actual quantities to derive all the resources we need to deliver the project is fundamental to any planning process. The next skill I refer to as scheduling or program control, and it's basically understanding how long a project will take to deliver and then understanding how to manage and control this during execution. So being able to look at a building, a set of construction plans, and working out what sequence it needs to be built in, what's the best methodology to capture this in a schedule, understand the relationship between all these different tasks, understand what the critical path is in the series of activities that, if delayed, delay project completion. Apply this to resourcing to work out what resources you're going to need when, what your peak resources are going to be. So scheduling, again, understanding when everything is going to occur is absolutely fundamental. Then we have procurement. Any construction project is going to be too big, messy, and complicated for one person to do or one company to do with completely their internal resources. So we're going to need to be able to engage external parties to deliver components of the work for this. If we're building a building, we might need an earthworks contractor, a concrete contractor, electrical, MEP contractors. So procurement is the process where we actually go through, understand, and engage external subcontractors to do work for us and sign contract agreements with. Skill number 6 is contract administration. So fundamentally understanding contracts with all these commercial relationships, both with our head contract and our subcontracts, are defined by, and then understanding how to read and interpret construction contracts, follow the rules set out, what to do as part of our regular ongoing tasks like preparing payment claims and monthly reporting, and also what to do when things change. And I'll talk about change control being a little bit independent. But again, it comes back to this idea that there's so much uncertainty involved in a project. We don't really understand exactly how it's going to play out. So change is going to be inevitable. From a commercial perspective, we have to understand what that change means. Now, cost control, you could sometimes I just toy up whether to include this as part of the estimating skill because they're very related. But if you can think of estimating as determining how much it costs to build something, cost control is then carefully tracking and manage as we execute the project. Are we spending less than we planned? We're taking our input data, the quantity of work completing, comparing this to how much work we have left to go, and forecasting out our cost to complete, identifying where we're going to overspend our original budget, making this comparison, and then putting in corrective actions. Basically, cost control is how we take the estimate and make sure our estimate is actually what we deliver the project for. The next skill we've got is risk management. So what risk management pretty much is naming what could go wrong while we still have something to do. And again, I spoke about risk a lot in the introduction, but to me, this is a very important concept to understanding construction. And it's basically, we don't know everything that's going to happen. So having a system to manage uncertainty and address what we both know we don't know, and importantly, don't know what we don't know. So again, this is this influence curve in action. We have the most influence at the start of the project, but we have the least information. The way we deal with the fact that we don't have all this information is through risk management. Then we've got quality management. So quality management is verifying and validating that what we are doing is correct as specified in the actual design. So again, I don't have time to delve into it here, but another important concept to understanding is this systems engineering V, where we think about the life cycle of a project. We have the early stage requirements. So we need a hospital with 500 beds. As we go through the design process, again, this is design management, we add more and more detail to this systems engineering V. So we go from having a hospital with 500 beds to working out we need X ICU beds and X normal beds. These ICU beds need these certain specifications. The normal hospital beds need these things. All of that gets captured in the design. That becomes our issue for construction drawing set. This defines exactly what we need to build to satisfy our stakeholder requirements. Then, once we have defined this on the drawing and specifications, then quality is all about installing things as per the design. So the design says we need to provide a certain type of light fitting in the operating rooms. The quality management is about checking, did we order the correct light fittings? Did we install them correctly? And once we've installed them, have we done a lux test to ensure they're actually operating as specified? So quality management is our system to verify and validate that what we had built is correct. Now, safety management, I would say, is its own disciplines, and it's the systems around to ensure that we're doing work safely and correctly. So things like safe work method statements, risk assessments before we do activities, plant inductions to ensure plant is correct and safe to use. Design management, again, it's the other half of that systems engineering V. So on one hand, we have checking that what we've actually built is correct, but the only way we can do that, and the only way that makes sense in the context of satisfying our stakeholder requirements, is we have this design management process before, where we go through the process of actually understanding what we need to build and turning that into a detailed set of construction drawings and specifications. And design management is the process where we control and manage that. And it's not just looking at the stakeholder outcomes, but it's also checking as we go through and develop the design, is it actually cost effective to build like this? And can we do it safely? Are we considering the risks associated with doing the work? Document control is this unglamorous skill that sits behind everything and makes sure everything functions correctly. When we think about all these separate functions, estimating, cost control, design management, drawings, specifications, contract management, different revisions of contract. Every set of these documents has different drawings, different revisions, and basically our ability to do any one of these functions relies on us having accurate and up-to-date information, and that only works if we have a good doc control system. Then we have stakeholder management and reporting. And a lot of this happens through the design management piece, where we're taking our clients' requirements and turning them into a set of drawings that actually captures what they want to build. Then we've actually got the function of delivering the project in such a way that we keep our stakeholders happy, which comes through reporting, keeping our stakeholders informed, understanding what the impacts we are going to have by delivering these projects on these different stakeholders. Then we have our change and variations management. As I've said multiple times, we cannot perfectly predict everything that is going to happen through the execution of the project. So we need a system to manage what to do when things change. We need to assess the impact of change, determine how it's changing our baseline cost, schedule, and budget, then cover ourselves commercially through contract management and variation management. Then the final skill, the most overlooked skill that everyone ignores, is commissioning and handover. So building something is one thing, handing it over to the operations phase of the project is another, which I refer to the completions, commissionings, and handover phase, which is basically looking at not so much what you actually have to build, but what are all the requirements you have to fulfill to hand over as per the contract. Spare parts, training, and operations and maintenance manual. Putting all of these together, working out what you have to do to handover, and then systematically working through, not at the end of the project, but as you proceed through the project, working out what you actually need to do to hand over the project, and then fulfilling all of these requirements. Okay, so the thing to next understand is that skills occur across phases. So even something like estimating, which you would think traditionally occurs at the start of the project, really we use estimating across every phase of the project. We use it in the initial pre-construction phase when we're determining feasibility, when we're negotiating a contract and we're actually quoting a project to deliver. We use it during the procurement phase where maybe we want to do a first principles cost check of one of our subcontractor patterns. We use it to price variations during contract execution. We use it to estimate the value of different risks during delivery. Basically, every single skill we have here will be used across the entire life cycle. Even something like commissioning and handover, we actually have to be thinking about what we need to do to hand over the project when we're preparing our initial estimate. Okay, rounding this out, coming back to this structure, we've spoken about the outcomes, safety, cost, and stakeholder satisfaction. We've spoken about the skills that apply across the project phases. Let's now finish this up by talking about the phases and why phases matter. And fundamentally, what a phase does is we take something unique, like a construction project, and we break it down to a series of phases that we'll go through on every project. In each phase, we know there are specific questions we need to answer before moving on to the next stage. So phase one, I'll define broadly as strategy and business case, which is working out what to build, deciding how we're going to build it, and actually deciding whether the project is worth doing to begin with. So we need to define the need, test the feasibility, determine what funding it'll be, so what the cost is, and agree on what success for our stakeholders looks like. This is where we have the highest degree of influence, but the most uncertainty. For example, we might determine that for our aquatic facility that we are going to build a 3-lap swimming pool with a jacuzzi and some other features, and it's going to cost $40 million to construct. We've also determined it's critical that we open it before next summer. The outcome of phase one is deciding whether or not to proceed with the project. Once we have decided to proceed with the project, we move on to phase two, which is the planning and design phase, which is where we turn this original intent into a defined scope, set of detailed construction drawings, a budget, and a baseline program. Now, a big part of this is going to be this design management piece and actually understanding exactly what our stakeholders want and capturing this in our detailed issue for construction drawings. So it's basically, we think of the design management piece is how do we transfer our set of client requirements into a defined set of requirements or technical specifications that show exactly what we're going to build. Now, clearly throughout this process, we also need to be carefully tracking the cost of what it is going to be to actually build this facility, because every new feature we add in our design, there's going to be a cost associated with building it. So we carefully have to always track, make sure we're not ending in what is referred to as scope creep. We're basically increasing the project scope without adjusting our original budget. Now, again, depending a little bit on the methodology we're using to deliver the project, but you can have design and construct procurement, or you could have a construct only. It depends on whether you're using a traditional or a different sort of more modern contract model, but using a traditional model where we're, as the project owner, doing the design, locking down the IFC design, then we can move into procurement party, the procurement process where we select the correct contractors to deliver the project through a competitive procurement process. We send it out to market. We get 3 to 5 quotes. We choose which contractor is offering us the best value for money solution, and then we negotiate and sign a contract. Now, if we think about where we are in our cost curve, once we've actually locked in a contractor at a fixed cost to deliver the project, almost the only influence we have over the end cost of the project is really going to be through variations and change, and basically giving them everything they need and facilitating their ability to deliver the project. So we want to be giving our contractor access to do the work. We want to make sure they've got everything they need. They're not relying on us for design or changes. But then we also really want to stay on top of how they're delivering the project and what they're actually doing using tools like Mastt, where we can keep track of all our costs, our schedule, our time to deliver the project. Basically, through the construction phase, we're using the trust but verify approach. We're giving our contractor, enabling them access to do the work, but then we're carefully staying on top of everything we're doing. We're paying attention to our cost, our risk, and our schedule. We're making sure they're doing it as they said they would, and they're staying on track to complete the project as required. And then the final phase of this project is where we actually complete and hand over the project to the stakeholder, to the operations and maintenance team who are actually going to be running it. And again, that's about understanding our requirements, such as operations and manuals, where we have to hand over spare parts, special tooling. All of these requirements to hand over the project need to be captured somewhere, and we need to be carefully ensuring that we're fulfilling all of these requirements. So what we've done there is we've spoken about this sort of project management framework where we have outcomes that we're working towards, our stakeholder satisfaction, our ethical responsibility to deliver the project safely, and our cost to deliver the project under budget. Then we have our skills we use to ensure this happen that work across the project lifecycle. And then we have the repeatable phases where we're working through the same things in every phases, whether or not the project is different. When we tie all of those together, we get a project management framework. So this video was about outlining and helping you understand the framework. If you want to dive into the critical area of construction contract administration, then watch this video next.